4.5 billion years ago, in the high-performance race to become a planet, this glistening blue sphere made it to the winner's circle. But the competition was filled with chaos and violent collisions.
But when the Earth was forming, rocks and boulders came screaming in much faster than the cars crashed when they ran into walls or on the cars.
After tremendous perseverance, it became a special place in the solar system to sustain oceans, land, and life.
Bacteria helped to create oxygen. We owe our heritage to the scum of the earth.
Despite modern disasters that now plague the planet, it still remains one of the most mystifying creations in the universe. Blast off aboard Spaceship Earth. Suppose extraterrestrials truly exist and want to tour planet Earth. They'd be in for the ultimate cosmic vacation. Earth, whose name may go back to the Greek word aras, meaning ground, is the third terrestrial planet from the Sun. But when arriving, visitors will realize that it got its nickname the Blue Planet because 3/4 of it is covered with water. And vacationers will see that Earth is the only planet in our solar system where humans or advanced life exists. If you can breathe our oxygen-rich atmosphere or breathe underwater, Earth can be explored without a protective spacecraft and spacesuit. But tourists will need to adjust their watches. It takes 365 days for Earth to orbit around the Sun. And each day is 24 hours, which is the amount of time it takes the planet to rotate around its axis once. Despite travelers' warnings about deadly storms and civil wars, Earth is a relatively safe adventure destination.
The Earth is a very special planet. Just like a Porsche is a very special car, our planet was formed in just the right place in the solar system. In fact, it's the only place we know of in our entire solar system where plants and animals can live under natural conditions.
Renowned astronomer Donald Brownlee has spent his career on a cosmic quest to solve the mysteries surrounding the origin of Earth. He says in the race to become a life-sustaining planet, Earth was in the driver's seat. But he cautions the ride was full of danger and intrigue.
The Earth had many things that happened to it to make it the way it is right now. And many of these things did involve luck.
4.5 billion years ago, one corner of the universe experienced a colossal fireworks display. A massive but short-lived star exploded as a supernova. The blast from this star may have triggered the gravitational collapse of the cloud that formed the Sun.
Shortly after the Sun formed, you had a lot of material orbiting around the Sun. And this was microscopic stuff, ice particles, dust. A lot of it wasn't unlike the lint that comes out of your dryer. And it began to kind of stick together in little clumps. And eventually, some of these pieces became more like sand, little pieces of silicate mostly, and it began to stick together, and you begin to get little rocks, little boulders.
As the boulders grew larger, so did the collisions. As two objects impacted, gravity held them together.
Porsches are known for speed. Planets are also known for speed. When the Earth was forming, particles and rocks and boulders came screaming in much faster than these cars crashed when they ran into walls or the cars.
Through multiple collisions, infant Earth was formed. But it would take many more impacts for it to become the size it is today. To better understand the formation process, Pete Schultz and his former student Seiji Sugita are attempting to recreate the early impacts on Earth by using the vertical gun range at NASA's Ames Research Center. It's a warehouse-sized room housing a massive light gas gun, which looks more like a ballistic missile. The vertical gun launches projectiles at specified targets inside a vacuum chamber.
The fact that this gun can load up in a different angle makes it really realistic in terms of comparison to what happened on the surface of Earth about 3.5 million years ago.
So we're going to fire this tiny quarter-inch aluminum sphere into the chamber. And we use this because it has about the same density as an asteroid entering the atmosphere of the Earth. So it's going to slam in around 3 miles per second, about 10 times the speed of a bullet. It's going to be smashed to smithereens.
The vertical gun will shoot the aluminum bead into the vacuum chamber filled with atmospheric gases. There, it will impact a sandy mound resembling early Earth's surface.
We're in a vacuum chamber that will be putting back in a gas that will simulate what the early Earth must have looked like. Let's go ahead and make a bunch of craters, what the early landscape of the Earth must have looked like, because these things are happening all the time. There had to have been a lot of craters. Okay. The plan is to come in, hit the center of the target, and watch the crater form. And you'll see the destructive power of this. Even though it's a tiny bead, it's going to do some real serious damage. Can you believe anything would survive?
High-speed cameras will document the impact. Schultz and Sugita nervously watch a monitor located outside the gun range.
This is the part that kills me. It's like this moment before the storm.
From a secure control room, an engineer flips several switches.
Okay, here we go.
Schultz and Sugita mix science with a little superstition.
Cross our fingers, cross our legs, cross our hands.
Okay.
This is what drives me nuts. Oh, gorgeous! Oh my gosh! Pow! Yeah.
Okay, let's take a look.
The experiment worked.
Look at this. Oh.
That is unbelievable. If we imagine this on the Earth,
Yeah?
these would be clouds that would be rolling at velocities that would be comparable to tornadoes.
Right, or even higher.
Even higher.
Yeah.
Let's see what happens.
The video taken reveals a frightening and realistic picture of what happened on early Earth.
That's a brilliant wake. Okay, let's go.
Oh man. Jeez. Oh, that is absolutely gorgeous. That did some serious damage. Just imagine that this is the asteroid that slammed into the Earth. This must have been happening just repeatedly, doing real damage to planet Earth. And it's just a small-scale example of what must have happened on the early Earth.
Yes! Yeah.
Some of the objects blasting into infant Earth were over 300 miles in diameter. The force of one such high-velocity impact created tremendous heat. Earth began roasting from the inside. Iron and nickel melted and sank to the core, generating heat like a massive furnace. The outer rock, or magma, was completely melted, producing a molten ocean. The planet was a raging inferno floating in space, literally hell on Earth.
the most severe impactors could have sterilized the planet. You get a steam atmosphere and heat the entire surface of the Earth above sterilization temperatures.
Formation of the Earth's core, sometimes called the Great Iron Catastrophe, occurred within the first 40 million years of our planet's existence, and it had a profound effect on our future. Within the iron core, the rotating ball of molten iron generated a remarkable magnetic field.
This set up the conditions for a habitable planet. By getting all the iron down to the center of the planet, you had a solid core that eventually drove the protective magnetic field that surrounds our planet.
Without the magnetic field, Earth would be an airless waste, devoid of life. A gusty wind of material speeds from the sun past Earth at 1,000,000 miles an hour and could erode our atmosphere to nearly nothing in a few million years. But Earth's magnetic field deflects the solar wind and preserves our air. But even with the magnetic field, violence and chaos continued to plague our planet. Above the Earth's iron core, its rocky mantle was melting, forming volcanoes that rose to the surface and burped up noxious gases and lava. And the collisions kept coming. One impact would forever change the course of Earth's history and the fate of mankind. About 50 million years after the Earth began forming, it experienced a collision that would steer it in a new direction. An object the size of Mars slammed right into Earth, which was already 80% of its total size. The explosive impact melted both the planet's outer layers and fused the two together to form a larger Earth. Some molten debris that didn't blend together coalesced to shape our moon. Planetary scientist Bill Hartmann first proposed this theory after NASA's first mission to the moon.
When the Apollo astronauts brought back rocks from the moon, and we could actually see what the rocks were made out of, they found out that the rocks are like lava that you can find on Earth, which tells you that the moon material and the Earth material are very, very similar.
Earth's intimate relationship with its moon gave the growing planet a competitive edge.
The moon is what causes the seasons, because some parts of the year the North Pole is tilted toward the sun, and later on the South Pole is tilted toward the sun. The moon holds that tilt steady. The various gravity forces that are exerted tend to act in a way that holds that steady.
After the epic collision which created our moon, our planet was over 90% of its total mass.
The planetary formation process involved almost a biological competition of many bodies bashing into each other at very high speeds.
When the collision subsided nearly 3.9 billion years ago, our solar system was left with 8 planets, or 9 if you still count Pluto. Earth secured the third orbital position from the Sun, which is now 93 million miles away.
Planets don't like each other because they're gravitationally tugging each other, so that they're equally spaced. Each planet is a certain fraction further from the Sun.
The objects that didn't become planets became refugees. Asteroids made of rock and iron found asylum in the asteroid belt between Mars and Jupiter. Comets composed of ices, dust, and rock sought shelter in the Kuiper belt just beyond the planet Neptune. Others migrated to the Oort cloud over 1 trillion miles from Earth.
These battered portions are a good analog to the early solar system, the comets and asteroids that have survived since the early days. And like these cars, which are kept here for their parts, we can also go to comets and asteroids for vital parts that have been stored since the formation of the solar system.
Over the course of Earth's history, many misguided asteroids have strayed off their orbital path and landed on our planet as meteorites. Over the years, scientists have analyzed these meteorites and determined their age through radioactive dating. And since meteorites were formed at the same time as our planets, they provide the age of Earth, roughly 4.5 billion years old.
Scientifically, this is fantastic. It's like looking into your family history and finding pieces of your first relative all the way back in Earth history. They're still out there.
Asteroids and comets may also shed light on the origins of water on our planet. $3.9 billion years ago, the Earth cooled, forming a thick silica crust over its mantle and iron and nickel core. Warm liquid soon covered the planet's surface, except for a few volcanic islands dotting the globe.
One of the Earth's lucky properties is that it happened to be born in just the right place. It's in what's called the habitable zone. It's the right distance from the sun, where its ocean does not boil away, or it's too hot, or too far away, where its ocean freezes over.
But where did Earth get all this water? One view is that water came from volcanoes, which have been around since the early formation of Earth. Volcanoes spewed out massive amounts of steam into the atmosphere. When the Earth cooled, volcanic steam condensed into rain and thereby supplied the planet with water. But where did the steamy water emitted from volcanoes come from?
Volcanoes basically recycle material from melted rock in the mantle of the Earth, including water. But that's not really new water, in the sense that it was there before in the oceans and is coming out again for the second time.
NASA senior scientist Michael Muma says our planet's water came from space. Comets, which are made up of frozen gases, could have showered Earth with water during the relentless impacts of its infancy.
The delivery of water from an icy body depends very critically on how large the particle is. The smaller bodies that came in would break up high in the atmosphere. The other bodies delivered their material to the surface of the Earth, and they can actually vaporize that material that becomes the water on Earth.
Muma is trying to determine if cometary water is made up of the same ingredients as our planet's water. We know that the Earth's oceans contain a mixture of normal water, H2O, and heavy water, HDO, which includes deuterium, a form of hydrogen that is twice as heavy as normal hydrogen. But comets are difficult to study. Few pass near our planet because most orbit in the outer solar system. But in 1986, Europe's Giotto spacecraft had a close encounter with Comet Halley, also known as Halley's Comet, which was 38 million miles from Earth.
One of the ways we analyze samples is to fly mass spectrometers through cometary debris that's coming off the comet when it's active. And we can measure the gases very accurately in this way. This was done for Comet Halley.
Comet Halley's water is similar to that on Earth. However, the other comets analyzed so far have twice the amount of HDO, or heavy water, that's in our oceans.
We know now, by looking at other compounds in comets, that they're not all the same. So we don't know whether Comet Halley was, in fact, representative of all comets.
Most comets studied thus far have come from the Kuiper Belt, located in the outer solar system. So, they probably didn't help form planet Earth. But the Gemini North Telescope in Hawaii recently discovered comets in an unlikely place. The asteroid belt, located between Mars and Jupiter. These warmer ice-bearing bodies may have the same water as Earth, because they were all formed in the inner solar system, which is closer to the Sun. What's more, startling new evidence suggests that these unusual comets may not only have delivered water to Earth, they also may have seeded our planet with the building blocks of life. The origin of life. It remains one of the most puzzling and controversial questions about our planet Earth. One thing is certain. 3.9 billion years ago, humans would have lasted for only a brief moment. The Earth's atmosphere consisted of carbon dioxide, water vapor, a little nitrogen, but no oxygen. Yet, could primitive life have endured in such an environment?
We have no firm evidence that there was life 4.3 billion years ago, but we think now that the conditions were possible.
The oldest fossils on Earth only date back 3.7 to 3.9 billion years ago. Some believe that these remains once evolved in ancient ponds or lakes. There, atmospheric chemicals and energy formed a primordial soup of amino acids, the essential elements of life. But could the building blocks of life have come from somewhere else? Perhaps from an extraterrestrial object?
Meteorites contain organic materials, including amino acids. They were formed somehow in the early solar system, so there is this delivery of organic material from space.
But if asteroids and comets gave the building blocks of life a space shuttle ride to Earth, how did they survive the high-velocity impact? Back at NASA's Ames Research Facility, Pete Schultz and Seiji Sugita are conducting another cutting-edge experiment using the vertical gun range. They hope to one day confirm that meteorites and comets could have delivered life's essential ingredients to Earth.
One of the things we are trying to look at, what is the survival of some of these building blocks? Can they be delivered to the Earth that would help seed a planet so the conditions for life could begin to exist?
Comets and asteroids probably brought essential ingredients for origin of life to the surface of Earth. That impact probably made the surface environment much more favorable for life.
Their experiments show that meteors delivered primitive carbon compounds to early Earth. Some of these compounds may have produced the building blocks necessary for life. But more research is needed.
Yeah.
So this is coming through the atmosphere,
right,
burning up as you go.
Yeah.
Still, many scientists agree the first life forms were single-celled organisms that lived in the oceans. And today, biologists are digging up the descendants of our earliest known ancestors in some of the most uninhabitable places on Earth.
If you had a big Cadillac today as modern life, ancient life was more like a bicycle. There are no remains of these organisms other than their chemistry. And I think it's important to keep in mind that for the first 2 billion years of this planet's living history, it was all microbial.
Professor Ken Nielsen is a bona fide microbe hunter. He scours the planet for the tiniest forms of primitive life that still exist today.
The earliest Earth was full of hydrogen, was full of hydrogen sulfide, had a lot of methane, some carbon dioxide. It was a place full of energy. The microbes exploited virtually every niche on this planet for energy.
Some have dubbed these early life forms extremophiles or thermophiles, organisms that can live in extreme environments.
Let's say there was a massive meteorite that hit the Earth, and the temperature of the Earth went up 40 degrees. Well, that would be just perfect for these extremophiles. One of the things we know, for instance, is that the, quote, oldest organisms, the ones that are nearest to the last common ancestor, are all thermophilic organisms. And you could say, well, that proves that life evolved at high temperature.
Descendants of these hot-blooded organisms can be found today, and they can live at temperatures of 230 degrees Fahrenheit.
If you want some so-called thermophiles, then you go to Yellowstone and you see these bubbling lakes and cauldrons of smelly water. And for years, people assumed they were sterile, but they're full of life, okay? And all these organisms adapting to that extreme.
Modern-day extremophiles may prove that life could have survived and adapted under the extreme conditions on Earth during its turbulent infancy. But how could single-celled microbes transform into complex life? Approximately 3 billion years ago, primitive life soaked up energy from the sun. Underwater microbes formed a green pigment called chlorophyll. This enabled them to trap sunlight and produce a chemical reaction which converts carbon dioxide and water into food. This process, called photosynthesis, led the way for bacteria to multiply into one of Earth's earliest structures, cyanobacteria, formerly called blue-green algae. Cyanobacteria injected vast amounts of free oxygen into the water and air and sparked the oxygen revolution.
All of a sudden, life divided into two groups. One that ran away from the oxygen and hid in the anaerobic part of the world, and the other that started using the oxygen as a great energetic advantage, and then could evolve, I think, to be much bigger and perhaps to evolve much faster. One thing is for sure, when the cyanobacteria got this ability, they outcompeted everybody else.
Thanks to cyanobacteria, life was able to quickly diversify and become more complex. Without it, molecular oxygen wouldn't exist. Therefore, plants, animals, and humans would have never developed.
So if we didn't have the cyanobacteria, we wouldn't be around. We owe our heritage to the scum of the earth.
All of us came from the same place. We have so many things in common with bacteria. There's just no doubt about it.
The Mojave Desert near Death Valley in Southern California appears void of life. But below the surface of this dried lake bed, mankind's ancestors thrive. Planet Earth's earliest life forms may have adapted and persevered under extreme conditions. Today, in the parched and barren Mojave Desert in Southern California, geobiologist Ken Nielsen is searching for the secrets to life. He's discovered that modern microbial organisms also thrive in some inhospitable places.
What you see when you glance at this environment are a bunch of what appear to be tunnels or mounds here, And these are made from the gases produced by the microbes living in this mudflat area. If we were to take water and rehydrate this piece of dirt and put this under the microscope, it would be rife with abundant microbes swimming everywhere. And this is the life cycle on the salt flat, all of which we call extremophiles, and which eked out an existence in a mudflat like this.
Microbes reign supreme for much of Earth's history. They revolutionized the planet and paved the way for a myriad of sophisticated species. But it was land that gave life a new home. It's believed the emergence of landmass began roughly 4 billion years ago. Plate tectonics created heat and pressure that produced rock lighter than the ocean floor. It ultimately floated and accumulated, creating continents that would change in size and shape over time. The presence of vast continents would enable Earth to sustain its most distinctive component: complex life. After 2 billion years of planetary and biological evolution, the first plants and animals emerged from water onto land. But it would take hundreds of millions of years before humans evolved. And once man claimed dominance over the planet, Earth would never be the same. Planet Earth now holds the best real estate for mankind in our solar system. 7 diverse continents and countless islands are home to 6 billion people. Yet, remarkably, most of Earth's existence thus far has been without humans. The planet's history has been compared to a 24-hour clock, with the presence of man being the last 2 seconds of the day.
We're driving around the track now at a relatively modest speed, and this car handles very smoothly, a very controlled ride. This reminds me of life on Earth. Life on Earth has had its ups and downs, but compared to evolution on other planets, the Earth has had a relatively smooth ride for billions of years. That's why life has flourished here.
But with mankind now navigating its future, Spaceship Earth may return to its tumultuous beginnings.
Humans, through trial and error of evolution, are suited to live on this particular planet. Now, that's true right now. We don't know if that'll be true in the future.
Earthlings created what once would seem almost unimaginable: technology. Mechanical vehicles, gadgets, and gizmos have simplified and bettered our lives. Many of these conveniences are run on or made using fossil fuels, which are harvested from the Earth's crust. But over the last 100 years, our innovations have gotten us into planetary trouble.
Humans are having a major effect on planet Earth with global warming and population explosion, so we're having a very large effect on the environment.
The natural greenhouse effect is the absorption of infrared radiation by our atmosphere, which warms our planet. Without greenhouse gases, the Earth's surface would be up to 86 degrees Fahrenheit cooler. But in the last 20 years, there's been an increase in greenhouse gases, especially carbon dioxide, produced by burning fossil fuels. The increased heating is affecting agriculture, sea level, and weather. In the past, carbon dioxide levels have spiked due to natural causes such as volcanic outgassing. However, today's rises seem to be happening much more rapidly. To visibly witness the drastic changes, one needs to travel to the barely habitable zones on planet Earth. There, mankind's future is literally melting away. The Earth's north and south poles are known as the cryospheres, regions blanketed with snow and ice. They help regulate climate temperature and water levels around the globe. NASA senior scientist Walid Abdullahi investigates the frozen parts of our world.
The feeling of being on the ice is amazing. It's pristine. In places, probably my boots have been the first to touch the ground there. It's very humbling. You know, you stand there and it's so vast and impressive.
But in the last century, scientists like Dr. Abdullahi have personally witnessed Earth's ice shrinking. The reason? Ice and snow are white. They reflect sunlight and cool the planet. By contrast, the open oceans absorb sunlight, which heats the globe. However, as ice melts, it creates more open water, which sucks in more sunlight and increasingly warms the planet and melts more ice.
It's unstable, we say, because even the slightest change tends to amplify itself. And it's essentially a runaway effect.
Earth's polar ice caps are in peril. Continually melting of these precious landscapes may one day produce catastrophes across the planet. At the South Pole, the continent of Antarctica holds 70% of the world's fresh water. Ice shelves surrounding the continent hold back ice like the Hoover Dam, but they are weakening. After 12,000 years of solidity, the Larsen B ice shelf collapsed in just 5 weeks. At the North Pole, some predict that the Arctic Ocean will be ice-free during the summer in the next 40 to 60 years.
What's causing the warm temperatures? Certainly there's an element of natural variability, but there is also a human contribution. We know that humans are contributing to the warmer environment, and that was subsequently contributing to diminished ice cover.
In Greenland, the Jakobshavn Glacier, one of the fastest flowing glaciers in the world, is now moving like a runaway train.
So it's now going about 5 feet an hour, which, believe me, for a glacier is very fast. The worst case scenario would be that all of these glaciers start to speed up and just deliver huge amounts of ice to the sea. That would be a 3-foot increase worldwide, and 3 feet in coastal regions is plenty to displace millions and millions of people.
Although humans may be able to stabilize man-made pollutants, it might take decades. At the same time, there are natural processes at work that might determine mankind's fate.
The planet's going through its own evolution. What we do on the planet affects us. It doesn't affect the planet. So we may muck up the atmosphere for a few thousand years of global warming and so forth, but this is actually just a blip. It's an important blip to us, but it's not necessarily a blip in terms of planetary evolution.
Don Brownlee and colleague Peter Ward have measured our planet's vital signs, and its prognosis is bleak. Earth, as a place for animal and human life, is nearing old age. Why? Our sun is getting brighter and hotter.
The problem down the line for advanced life on Earth is that as the sun gets slightly brighter, the expectation is the carbon dioxide will be almost completely removed from the atmosphere. There will be an end to the age of plants and animals.
Humans could die out 500 million years from now due to the brightening of the sun. But in the grand scheme of things, man may have had a good run. Before reaching extinction, perhaps humans will have lived longer than any other complex species because of their ability to adapt to changing environmental conditions.
From a human standpoint, the Earth will remain a portion planet probably for another 500 million to 1 billion years, which is a truly awesome timescale from a human standpoint.
As Spaceship Earth maneuvers through uncharted waters, humankind can reflect on the planet's awesome achievements and steadfast survival in the tough neighborhood called the universe.